Sunday the 1st of April, and I'm taking a break from all the work and still on the subject of crystal radio. This again is for fun and it's for people who are interested in it, and I repeat again, if you're not interested in it, well then there's no point wasting time. Please don't. There's plenty of other good stuff on the channel without watching stuff you're not interested in. But it's amazing how many people are interested in this, and I for always intended to try and make my own radio because it's in the blood. My father and my uncle used to make them and they were the whole go. I just want to have to say I made a radio and I heard something on it. Now it's 44B is the number, and we're just going to look at what you need, what the components are. Now when the signal comes in, it's alternating current, as I've shown you, it's a wave. And that wave carries on it certain information by the way it's modulated at the station. I won't go into it here. But that alternating current cannot be converted into an earpiece signal. The earpiece or any speaker or any loudspeaker or any telephone works by a tiny electromagnetic variation that works a little diaphragm that causes sound into your ear. It hits the air inside your ear or in the room you're in to cause you to hear the vibrations of sound. So you're talking about the vibration of sound, and we have an extremely good detector in here, just in there, and another one this side. And this is better with me than this one because I shoot a lot, and this ear gets more of the muzzle blast from the gun than this one. But there's not that much difference. So what do you need? The signal's coming in like a wave. It's no good, but that doesn't mean you can't hear something. It has a frequency of many thousands of hertz, and we'll be looking at that. So there is a sound. And did you ever turn on, especially an old valve radio, even some modern radios, you'll hear a hiss, a bzzz, kind of a buzz. That is the modulation, or that is the frequency, maybe 70,000 times a second, changing back and forward, and it's causing a small electric field in the earpiece that you can pick up. It's converting it into interruptions of the air. It's hitting the air like that, and that causes sound, the vibration of sound, which your ear picks up and transfers into the brain. So you have the power station taking electricity from a power station. You have it sending out this by means of putting energy into the atoms in the transmitter. It comes out through the air and it's earthed to the ground. And here we have an aerial outside, and it's picking it up in the form of alternating current. And I have it here at the end of a piece of wire, and I have an earth here as well. Now, the problem is that must be changed down to direct current. You must cut out the wave. And so what actually has to be done is, I'm going to draw it here for you folks, is you have to cut out half the wave. So here is the wave, like this. You have to cut out that, and then I get another biro here, another pen here, and I'll put the other one in red. Do that. So if you look here, this is very roughly done. Do you see the way the waves are? These waves go down under the line. In other words, it's like this. You've got to cut out the bottom part. Otherwise, the signal you get in will just be a hum. And when you cut out that bottom part, you can get what's coming in by way of intelligible sound. Both provide sound, but the one provides more intelligent, more intelligible. You can understand it. And to do that, you need a very delicate diode which lets the power flow in one direction. They used to use a razor blade that was burnt for foxhole radios, but nowadays, and even back to the 20s, they use a little piece of germanium, which is an element that was originated inside of dying stars billions of years ago, millions and billions of years ago. And here are the little germanium diodes. You get a lovely big supply of them. About €9 you get all of those, right? Look at the little fellas. There's the germanium diodes. Now, the number it gives on these, if you're buying them, is 1N34A. Now, as I understand it, long ago they were all 1N34. Now, there is another type of diode called a Scotchy diode. If it says it's for It's for crystal sets. It might work. I'm not saying it won't. Some say they're actually better. But this contains a tiny little piece of germanium, and germanium allows current only to flow in one direction. But it's not 100% effective. It's about 95% effective. And so there was a cat's whisker long ago, where you had a piece of maybe germanium, a big lump of it, and you had to move the whisker around to get the best pot. But these are static, and these are the modern world. But these are germanium diodes, so I'd recommend you go for them. 1N34 or 1N34A. Oh, can you see that? I don't know. Well, I think you may, but I'm giving it to you there, and it'll all be below in the comments section anyway. So that's that. So that goes between the incoming power here. Where is this here? I've shown you this already. It's very awkward because I have nothing cut to size. It's just a matter of getting it done. Once I get it to play a song or two, I'll be happy enough. So that goes between the incoming signal and the earpiece, and that cuts out half of the signal, leaving you the rest. And these are known as detectors. They call them detectors. That's what they actually do. They're diodes. Now, in old radios long ago, they did that by means of valves. They hadn't semi-state stuff. These were one of the first semi-state things that they ever made. It wasn't for years later that they came up with the transistor and all this stuff, and were able to do these by means of silicone and all this sort of stuff. They used bulbs like for radios, kind of valves. But in any event, that's that. The next thing you will need is you'll need resistors. Now, I didn't bring the box. I got the resistors in. Again, I'll post it below. I have them all in the one box because they're very easily lost. Now, the function of the resistor is a bit not too well understood. It appears that when the signal comes into the very delicate earpiece, it's not in the best form. You need to oppose it a little bit, because the way they make the earpiece and the way the earpiece has to be made, it can result in problems. Indeed, if the signal was too strong, if you lived right beside the big transmitters in Dublin, you could blow the earpiece one, because they have to be set at a certain delicacy. But this is the little resistor, and I'd say you cannot see it there. I'd say you safely cannot see it. You see it there. It's a small little thing. Now, again, these are received from the various suppliers, eBay and Amazon being one, and I'll try and supply more on that. And of course, it says on this made in China. In China? But it is. But that's the diodes are made in China. But that's the little resistor. Now, there's various diagrams as to where that goes. One is that it goes between the earth and the other one, and the earth and the aerial. There's another diagram showing where it goes between the aerial and the earpiece. So what we're going to do here is, well, we may not do that just yet. There's the two things you need. The little resistor and the diode are essential. You can't go on with that. But you can get a hum. That's the point. Now, the next little thing, and it's great that you can buy these. I mean, these are cheap. These are made apparently in England, and I think this is the last supplier. And it says SoundLab cream mini earpiece with 3.5mm jack. And there it's there. You won't read that. But here is the little piece. There it is. See it? Now, can you see that? There's only one maker in the world. Might be no harm to buy them anyway. Like they're not. Yeah, the student or something. This would be an excellent project for students doing electrical engineering. But that's the little earpiece. Now, these all work on the minutest of power coming in. They just work on minuscule power. Okay. So now you have the 3 bits. Now, what I will do with this is I'm going to cut off that jack because I have no receiver for it. I'm going to cut off that jack and just use the little wires as they are. They usually send you a few. I think these are about $3.50 each. I bought a couple anyway. So now I think you understand the situation. I'm going to pause now to give you a rough idea of the diagram and put this stuff safely away. I don't want to lose it. And I'm going to give you, I'll just pause and give you an idea of the diagram that I will be trying, which seems to be the most popular one. There may be variations, and we'll pause there a second. Now we're back again. I got that done successfully. Sometimes the smartphone it goes out, it goes off when you do that. It's just awkward that way. Anyway, what we have here now, folks, the right way around is you have the aerial here. See my finger here? It's the aerial. The wire comes in here. Here you have the earth here, and it comes in here. Now across the two here you have the resistor. See them two? This is the one I'm going to try. So across them two you have the resistor or and here's the stator. So here's the resistor across the two, directly across, and that makes it more. I mean, it seems to work better. Its exact position, it suits them little ear pieces, and it regulates the power a little bit. They're very, very delicate resistors, and they're very cheap. And then down here, then you have the earpiece. See it here? But vitally here you have the diode. You have the germanium diode here. So the power coming out of the area is cut in half. Only half it's let through. This resistor controls the force of the electric current, alternating electric current, and it goes into your earpiece here. This is the earth. This is the earth. So have you that diagram? Now, folks, I see I'm on 11-15 minutes. Now it's very risky for me to continue. Now you'll notice in this I haven't yet started with any kind of solenoid or coil to get various stations. What I intend to do in the next video is simply see, can I get what will happen if I try to work out that circuit without any big flashy stuff at all, maybe a bit of sellotape or a bit of insulating tape, and just see what's going to happen now without going to too much extra trouble and without you having to go too much extra trouble. I'm on 11 minutes 48. Give me a thumbs up for effort. It is difficult. It's not that it's so difficult. It's experimental, and it's also difficult holding things and getting the camera not to give up in the middle of it and all that. And again, this is for a bit of fun to see what's going to happen. Can we run a radio without any battery, any power source whatsoever, using nothing than the signal collected in the wire? That's the big question. Does that work or does it not? And I have the bits here, and I'd like to share that with you. So folks, thumbs up and a thumbs down, and we'll see you back for it'll be 44AB. Next one should be 44C. I think we're 44, 44A, 44B, 44C. And I will not be using any politics or anything on 44. 44 stays for technical stuff. Okay, thank you very much.